Hello and welcome back. Today we're going to go over mouse and keyboard input. So if we just look at what we had before, it should just be our colored rect. And so I want to make it so that moving the mouse changes the colors, basically, just to ensure that everything's working properly. Maybe I'll print out the mouse position, just to make sure that everything is there. Now SDL gives you this. You're able to ask SDL for the mouse positions. But I always do an additional layer of abstraction, really just because I want to make sure that I can grab the previous frame's mouse or keyboard position as well. So that way I can tell if a button has been just pressed on this frame, just released on this frame, or if it's just held down at all. So to start, we're going to add a new folder to under Hippo here. We'll call it input. Same with the source. And I'll just add a mouse.h and a mouse.cpp. Now you might be wondering, like, why is this not under its own sort of manager under the Hippo engine? I think managers have their place, but for something like an input from an external device, like an HID, human interface device, I think it's fine if it's just a static interface that anybody can access and use. We can also hook this up to an event system that is driven by the engine eventually, if we choose to do so. But I very much think it's much easier to just ask for mouse or keyboard state statically. So we'll just go ahead and start here with the namespace. We'll have our class mouse. So when we start thinking about what this interface is going to look like, somebody's going to call it like this, right? They're going to say hippo input mouse, and then it's a static function, so you'll just call it like this, and then we just ask for data, right? So maybe we'll just call x, and this function will return the x position of the mouse, right? Or we'll say like button down, right? So was a mouse button just pressed on this frame, this sort of thing. So this is what we want to expose basically from our static class here, and everything will come from SDL. So we do need an update method here to sort of, once SDL has done all of its polling for events, we can update the mouse and get the latest mouse state from SDL. So we'll start with that. So a static void update, where we'll do that, and then we'll have our sort of getters and setters. And really it's just going to be getters because the update will set everything for us. So we'll want to be able to get the x position, and we'll store that locally, so we can have an inline static int x, return x, and we'll just have to make x. So again, everything's static, so static int x, and we'll want x last as well from the previous frame. And we'll do the same for y. And you can see this is sort of a style thing. I usually put m sort of for member variable and before anything, but for static methods or static classes, for whatever reason, I treat them like structs and I don't put that in m. It's just, I don't know where I picked that up from, but it's what I do. So there, this will do x, and now we'll do y as well. And now we want to ask if a button was pressed, right? So is a button down, is a button up, or is the button just held? So obviously to ask for that data, we need to store it somehow, and I'm going to store it as an array. And we'll use the std array here because we could use C-style arrays, which is what I actually have done in the past, but std array exists and it's nicer to work with, so we'll do that. Now array needs size, and we know the size. If we look at SDL button left, this is SDL sort of defines for all of the mouse buttons that it supports. You see it supports left, middle, right, and then 2 additional sort of extraneous buttons. So in total, it supports 5 buttons, so we will also support 5 buttons. So if we want to set up a std array, static std array, and it'll be an array of bools, and we need to give it the size, we'll have a button count, and we'll call this buttons. And that button count needs to come from somewhere, so we'll define it up here. It's got to be const expr, so const expr static const int button count equals 5, and we'll just say SDL supports up to 5 mouse buttons. See SDL button left, so that way you can alt G on it, and it'll take you to where you need to be. So that's set up for buttons, and buttons will just be the current state, and then we'll say buttons down So, and buttons up, this will be the buttons, like whether a button was just pressed or just released on this frame. And regardless of whether it was just pressed or not, this will tell us if it is still held. Right, so you can imagine that pressing a button, the left click will have its buttons down turned on for one frame and then off for all the other frames because it wasn't just pressed, right? That's where you start looking at buttons. So I'll start making sense a little more once I start building it. And then up here we'll just ask for this data, right? So a static bool button down, we'll take a button, and it's an int. These are going to be ints as you saw in the SDL side of things. So button down, button up, and button. Maybe just to keep it consistent, I'll do button, button down, and button up. Okay. Now I don't want the callers passing in 0, 1, or 2 or whatever it is, especially because it doesn't even start with 0, right? Like left starts with 1, like 0 is not a thing. And these defines won't be available for the caller or for the client app because they are not including SDL headers. So instead, I have to sort of create my own abstraction of it. So I'll just do that here with an unnamed enum. I use unnamed because I don't want the API to be like this: hippo input button hippo input. Let's say the enum was called like mouse buttons, or probably even mouse buttons left, right? Like this is just too much. We already use namespace liberally, so instead, if I use an unnamed enum, if I was to call the first thing hippo input, and because it's unnamed and it's a C-style enum, we do need, like there can be clashes, so we need to make sure there are none. So we'll basically replace this hippo : input with a hippo _ input _ mouse _ left equals 1. And we'll do this for all of them. So 1, 2, 3, 4, 5, and this was x2, x1, right, oops, and middle. So now by using this, as long as I'm including mouse.h from the hippo library, I should be able to just say hippo : input : button, and then hippo input mouse left. That just feels better to write. So that's how I'll do it. And then that's what I'll be passing in sort of for these. And again, everything's just being checked against SDL's values anyway. So now we can switch over to the CPP if we've built it, which we have, and we can start asking for those data. So first things first, include hippo, and remember we just made this a thing. We have to include it with hippo / input / mouse.h. And then we'll include log as well, because I'm sure we'll want to log stuff. Actually, we might not want to log stuff. Actually, we would, because we might want to assert. Let's just do it now, anyways. And anyways, we'll start with the namespace, hippo input. And then, because everything's static, I do need to sort of define what these are, right? They're static, so I need to call them out here. So it's an int mouse x. We'll start everything at 0. It's x and x last. And same for y. And this same goes for std arrays. Like, again, they are what they are, so we do need to define them up here. And I think we can just do this. We just have to do mouse. Yeah, because the std array will initialize everything. Actually, it might not. Either way, it doesn't matter. Our update will stop everything with falses anyways. So if we let's write that now, mouse update. And then here, we're going to, we'll keep track of buttons. Like buttons will persist from frame to frame, but buttons down and buttons up will always be cleared at the start. And that's because we want, buttons will basically just be copied from SDL, and down and up will just be set if buttons was on or off the previous frame compared to this frame. So if we include algorithm, we should be able to use std fill. And we're going to fill buttons down dot begin, buttons down dot end with false, because it's an array of bools. We'll do the same for button up, right? So again, we're going to clear down and up because those are going to be set this frame because their context is about this frame in particular. And now we're going to call the SDL call. So we actually need to include SDL2 / SDL _ mouse.h, which will give us access to that mouse method. It also gives us access to SDL. They use an internal abstraction to like even32 _ t and that sort of thing. And that is what the SDL function returns. So it'll be a uint 32 called state, and it'll equal to SDL underscore get mouse state. And what it does is it returns a bit flag for the buttons that are pressed, and it will modify the X and Y positions that you pass in directly. So we'll have to pass in references to X and a reference to Y. Okay, so now we have the latest X and Y, and we have the button state here, which we need to now go through and set up our buttons arrays accordingly. So we'll iterate over our buttons. So for int I equals 0, I is less than button count, I plus plus. We can basically check, because we haven't filled our buttons yet, we can check if it was filled the previous frame. So we'll just have a bool was down equals buttons at I. And then now that it was down, so now we've captured that, we can actually update buttons at I. Buttons at I equals state. And the way you do this is, again, it's a bit mask, so you can say state bitwise and with SDL underscore button, and then it wants the ID, so these 1, 2, and 3, so it's not 0, it doesn't start at 0, it starts at 1. So we'll pass in I plus 1. Right, so for button 0 in our sort of index into our arrays, that will be the left mouse button, which is 1. And now that we've updated this, we can say bool is down equals buttons at I. Right, so was it down and is it now down? And with those two pieces of information, you can determine whether a button was just pressed or just released. So let's do that. If it was down and it's no longer down, then buttons up at I equals true. Right, so you can see we're just setting the flags. Buttons up at I equals true, and then else if it wasn't down and it is down now, then buttons down at I equals true. And that should do it. So let's just go over this one more time. We grab whether it was down on the previous frame before it was set, and everything, I guess this never got initialized to 0, so the first frame might be weird. We might need an initialize method here, just because I don't know if there's a way to initialize everything to false. So I will add an initialize method here. And initialize will just std fill buttons to false. But let me know if there is a way to just do it in line here. Like, I wonder if I can just say, actually maybe I can just do this. Like that looks right. I really don't remember the syntax if this is gonna just initialize the first one. And because it's internally it's a C-style array, like if I have to say false, 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 which will not scale well when we deal with keyboard input. So I'll just have it initialize, we'll set it all to false in there, and let me know if there's a better way to do that. So I think this is good. Buttons gets initialized to false, and the update will initialize the other two to false every time. Maybe we should initialize all three just in case you initialize, you don't update, and you try to read the state. Everything should be false. Okay, that's pretty straightforward. So now let's go ahead and implement these three getters, right? So here for button down, we need to sanitize this input, like, so just not even sanitize, just balance check it. So we'll also assert here, I think, hippo assert that button is greater than or equal to 0 and button is less than button count. All right, because we're going from 0 to button count. That's how our enum is set up. Actually, is that true? No, it's not. We're going from 1 to 5. So maybe we just do a hippo input mouse first equals 1, and then left equals first, and then 5, and then hippo input mouse last equals, I'll just say the number here on this side, because it'll be easier to update this to the number than it is to update this. And I mean, I really don't even have to define these numbers this way, but this is what SDL does. I'm going to be very explicit. And maybe I'll even say that here, like adapted from SDL, CSDL button left. Right, so now I should be able to bounds check against mouse first inclusive and mouse last inclusive. So it can be any of these, or I can make this count. Ooh, but if there was a gap in the numbers, like there might be on the keyboard side, that might not work. So we'll just say first and last, because count implies it's the actual count, but that might not be the case. Okay, so anyways, we can do an inclusive bounce check that way. So button is greater than or equal to hippo input mouse first, and button is less than or equal to hippo input mouse last. Otherwise, invalid mouse button. Good, and so then we'll just do another. You'll, again, I think I mentioned this before, usually an assert is followed by an if statement with the same check. And so then if it is good, then this is the button query, so we'll just return buttons at button. Otherwise, we'll just return false. Now we'll do the same for buttons down and button up, and we'll just check buttons down and buttons up. Okay, and that's pretty much it. That's all we really need to do. Now we just have to make sure we call initialize and update in the right places. So if we just go over to our engine, for initialize, we should definitely do it in its initialize once we're good. So here, we've created the window. If we successfully did that, initialize the render manager, set all of our internal states to initialized, and then we'll just initialize input here. So let's include hippo input mouse, and then here we can just call hippo, we're already in hippo, so input mouse initialize. Cool. Now the update, we'll want to update the mouse state after we've pulled all the events, and that happens in window.cpp. So pull event right here. Once we've done pulling all the events, we can just update input. And again, we'll include hippo input mouse. And now from here, we can call hippo, again, don't need hippo, input mouse update. And after this happens, we are free to actually check the mouse state. And this is good because this will be guaranteed to happen before we get to actually updating any of the client app. And if we just go back to the engine real quick, if we look at the update loop, so run here, if we initialize, we initialize our stuff, and then here, so we pump events, and then we can start doing stuff. Again, it's once we get to something like a client app where this will be abstracted out, we'll actually call into the client app to update itself, and that'll happen after we pump events, so we can enforce that. But for now, why don't we just print the status of the mouse? So hippo, let's just say trace X, Y, and then just the buttons, 1, 2, 3, 4, 5. And again, I don't have to ask for any object. It's just statically available. So we'll do input mouse X, input mouse Y, and then input mouse. I'll just check the button state for each one. So hippo input mouse left. Oops. Right. Actually, it's middle next. Not that it matters for a print, but just so it's the same. And then X1. I don't even know if I have X1 and X2 on my mouse. But let's try that. Alright, we had a couple issues with a couple things. So let's just go back through and check. Button count, yeah, of course. Button count is part of mouse. I need to define that there. There we go, that fixed that. So it should be good. And search, okay. Array subscript out of range. And this is where when we're trying to get the button here. Oh, sorry, assert failed. Oh yeah, of course. This button starts at 1, not at 0. So when we try to get for button 5, we're asking for too much. We're going out of bounds here. So yeah, we want button -1. Okay, and there we go. And you can see I'm printing a bunch of stuff, and of course these are falses back to back. But you can see that the X and Y positions are working. So from SDL's point of view, 0, 0 is top left. Now you know from when we rendered this that OpenGL's coordinate system starts at the bottom left. So it's -1, -1, and it's bottom left instead of top left. So that's something we'll probably have to map. Really, just take that Y value and subtract it from the height of the screen, and then we'll get sort of a Y value that coordinates between both SDL and OpenGL. But anyways, we have the position here, and then the 5 buttons. So this is my left click, which is the first true, right click, the third true, middle click is the second, and then I have 4, but I don't have 5 on my mouse, so can't test that one. But you can see it's all working properly. So let's stop printing everything. And let's instead do something interesting with it. So if we just look at our shaders here, we have a position and then a VPOS, which is what we're passing in. And we're setting a color to a VPOS. We're not even doing this color uniform anymore because, this is because we wanted that interpolation. So that's good. We could even just, instead of adding this 0.5.5, that'll be our offset. We can use our X and Y position of the mouse to define what this offset is. So we'll just do that as another uniform. So uniform vec2 offset, and we can initialize it to vec2 0.5 just so that we have what we had before, and it'll be vec3 offset and 0. So we'll never add blue, we'll just offset the green and the red. And now down here we can just set that uniform based on the X and Y position. Now the offset, like, colors go from 0 to 1, so we do want to normalize our mouse positions, right? As soon as we go past 1, it's just going to be all white, basically. Not all white because we don't have blue, but if we normalize it across the width and height of the screen, then we'll be able to have a more gradual transition in the color. So in order to do that, we need to have the window's width and height. I don't think window exposes that right now. It does not. So why don't we expose the window's width and height here? We'll just do it here. Void window, or get window size. Actually, that's Windows redundant. Get size. And we'll just take in a pointer to a width and a pointer to a height. We'll modify it. Actually, let's take them by reference so they can't pass a nil pointer. And then on this side, we just say SDL get window size, and we pass an M window, and then they want pointers, so we'll have to pass references to W and references to height. And there we go, so that should get us the width and height. So now engine.h, I don't think exposes the window itself. It does not. So we'll have to do that here as well. Inline core window, reference, get window, turn on window. Now that's all exposed, and actually, you know what, now that I think about it, we're asking for the window stuff from within engines, but it doesn't hurt to have this exposed anyways. I'm sure the client app will want to know width and height as well. So now we can say int window width equals 0, int window height equals 0, and then just get the windows. So actually, we don't even need to do that. Let's call the method we added. So get window dot get window what's it called? Get size, and then we'll pass in window width and window height by reference. So now window width and height should be set. So if we just trace window width and window height real quick, and I have to do this, I think. Let's just make sure we get values out. Yep, 800 by 600, and I can resize this, and you can see it does resize properly. Cool. So now that we have that, we have the x and y position of the mouse, and really we just want to store them into a value that is the normalized value. So when we say float x norm equals input mouse x divided by window width. And these are ints, both of them, so we'll have to make them floats before the division in order to ensure that we get a proper normalized value instead of just a 0 or 1. We'll do the same for y, divided by window height. And then we'll just set it on the shader, right? Shader set uniform float 2. We call it offset, and we'll pass in x norm and y norm. Right, so when we ran it, you saw it was still 0.5, but now we should be able to modify that offset based on where the mouse is on the screen. And look at that. I don't think we're printing anything anymore, but you can see that it's working properly. So if I go bottom left, or actually this is 0, 0 up here, right? So 0, 0 is top left. You'll see what we saw in that first video when we actually started building this, right? So half of the rect is black because it's going from -1 to 1. So the 0 is right in the middle, and then everything above that is more green, everything to the right of that is more red, and obviously that diagonal gives you a slight yellow. And so as I shift up the x and y, I'm moving that offset up on the x and y. So here's the x, here's the y, and I can do both, and now we should get a much more yellow yellow color here. I think if we had full blue, this would be full white now because we're at +1. And so somewhere in the middle, we should have that what we had before. So that 0, 0 is now at the bottom left of the rect, which is where the black starts, and then it gradually goes into a full green at the top, full red on the right, and full yellow top right. So there we go, that's it for mouse. That was pretty straightforward. I think maybe we'll just subtract the height of the window from this before we do it, just because that way it's at least aligned with OpenGL's coordinate system. We'll do window height minus the y position before we divide it by the window height, and that should properly flip it on the y-axis. So there we go, up, right, and both directions. So that's it for the mouse. That wasn't too bad. The keyboard will be very similar, it's just going to be more keys. So let's just do that now. So we'll create the keyboard files. Keyboard.h, keyboard.cpp, and it'll be very similar. I'll just copy and paste it, and we'll modify it in line. That's never bitten me before, right? Hippo input keyboard. Again, we'll have an initialize and an update. We're not asking for x and y. We're just asking for, these aren't buttons, they're more like keys. So key, key down, key up. This will be called key. Perfect. So for this stuff down here, we don't need this x last, y last, it's just the button stuff, but the button count, so we have to go by SDL num scan codes, which is internally how it determines what the keyboard turns. So you can look at SDL scan code. This is how we ask for keyboard state. This is what it'll give us the state in. So you can see unknown is 0, and then it skips a couple, and then goes into all of the possible keys that it supports on your keyboard. So this will be harder to just rewrite from scratch. So I'm just going to take this entire list, and I'll just start at A. I don't need the unknown, and I'll just switch to Sublime Text. So if we just pasted it in, just zoom out a little bit. So just Shift Tab everything, and I just want to sort of remove all this extraneous comment stuff. And there's probably a faster way to do this. So let's see. If we use regex or regex slash anything that's slash star slash backslash star dot star can be removed, because that'll be either at the end of a comment or at the start of a line of comments like this. So we'll just replace that with nothing. So now that we've cleared everything at the end of the lines, we should just delete anything that isn't SDL scan code. So I'll use a caret for the negation, and then I think I have to double scope, question mark, exclamation mark, SDL scan code, STL underscore scan code, and then I can close it, and then anything at the end, and then star. And $sign will give me the new line, I think. Maybe I don't need the $sign. Yeah, I shouldn't need the $sign. Actually, if I do the $sign, it should capture a line that goes all the way to the end. This will be easier to see things that it doesn't pick up, like this line here, because this is in a comment. So that, Control Shift Enter. So now I should very easily be able to see what isn't STL scan code, and maybe I'll just replace double new lines with nothing. Yeah, there we go. Oh wait, that didn't do it. Replace double new lines with a single new line. There we go. So let's just do that a couple times. There we go, got it all. Okay, cool. So if we just go up here, anything that isn't STL, there we go. That should be good. I'm noticing there's a space after we come. That's fine. Okay, so now that we've got this, we can just replace STL underscore scan code underscore. Actually, I'll keep the underscore with hippo underscore input underscore key. Yeah, hippo input key and then the key number. So let's replace it all and copy all of that, paste it all, and yeah, so key last will be 286, and key first will be 4. Actually, will be this. Okay, I think that makes sense. We'll just say adapted from STL, CSTL, and scan codes, and then yeah, for these, so button count, we'll just rename this key count, and it won't be 5. STL supports up to 512, but we're not using that. Like, we can save on 300 bools times 3 by just using last instead of STL num scan codes. So why don't we just use last, and instead of 286, we'll make it 287. This will be the last one that we support, and because yeah, if I look at this real quick, we start at line 1 and A is 4, and I don't think this actually just goes up contiguously all the way across. Like, I think there's gaps. We might not be able to spot one, but if we just go the bottom, line 242 has 286, so there's 40 missing somewhere in the middle. And I'm not, gonna spend too much time trying to understand what they skipped and why. I really think just as long as we can cut off those 300 or so bools at the end there, I think that would make things better for us. So I can just use, and actually because I won't know what this is at the time of this, I think I'll just actually remove it. And then I'll just make it here be 287. And so then I'll say 286 is where it ends, so STL supports up to index 286 CSTL num scan codes. And so we'll bounds check up to 287 because 286 can be a thing, and key count is our array size. So we'll make these keys down, keys up, and that's good. Our bounds check will just be between first and key count, not inclusive for key count there. Okay, so a little bit different from the mouse, but that's okay. Now let's switch over to the CPP, and really we're just going to take the mouse one and sort of adapt it. So, copy and paste never hurt anybody, right? That was a joke. STL keyboard, and then yeah, we don't need these. This becomes keyboard key count keyboard keys. There we go. So initialize, we'll initialize everything to false. Oops. This will be key up, int key. And And yeah, so just go sort of work from the bottom up. So hippo assert that button is greater than or equal to hippo input key first, and button is less than key count. And of course, button is actually key. And then invalid keyboard key. There we go. And then we'll just do the same check in here. And if we're good, we'll return keys up. This time it's at key, because we know that we're bounce checking against the at key +1, basically. So that's for keys up. Now we can just use this for the rest. This will be keys down. This will be keys. The word key is starting to look like it's not a real word. Okay, and then scrolling up, keys. There we go. Initialize everything to false. When we update, we'll initialize the down and up to false. And then instead of get mouse state, it's get keyboard state. And get keyboard state. So it takes in this num keys as an int pointer. This will just tell you how many keys are returned in the array. So as you can see, it's returning a const uint8 star. So this is actually an array of keys, and in this value, if you pass something in, you can actually ask how big that array is. For us, we don't need that because we know. Let's do null pointer. Because we know that we are only going to check up to key count, and we know that we're well below what the max would be. So for stl underscore get keyboard state, for some reason it doesn't like that. Oh yeah, because it returns a const uint8 star. So const uint8 star state. Okay. Now again, I did mention that 0 through 4 will never be used. Like they're not used by STL. So we should just start this at first key and go until key count I++, and then bool was down. This will be keys, and because I'm getting an array where there's no mask here, we just say state at I. So keys at I equals state at I, and because we're making it like this direct copy here, that's why we can use at key down here. Okay, moving on, keys, and you can see this logic stays the same, right? Now that we have our previous, we stored sort of the keys state from the previous frame, we can just use the exact same logic as we did for the mouse to toggle, to check whether it was just pressed or not. So that should be it for keyboard. So now again, we'll just call initialize and update in the right places. So if we go back to engine.cpp, where we initialize the mouse, we'll also initialize the keyboard. Similarly, in window.cpp, we will update the mouse and update the keyboard. Okay, so now we can put this to the test. So engine.cpp. Up here we have this offset. So maybe what we'll do, and we never really checked like the down, like is it down on this frame and only on this frame sort of thing. So maybe we'll do that here. We do have keyboard, so we can just say we're setting x norm and y norm here. Why don't we just also say that x norm, or if hippo or input keyboard, let's say key down, I'll just pick R, and this will be hippo input key R. So if I was pressed down just on this frame, I'll say x norm plus equals 1 point f. So what I'm expecting to see here is that we see sort of a flash of a different color just for one frame when I hold down the R key. So what I'm going to do is, and I guess I should go back and try to fix this. And yeah, of course, we don't have key A. In fact, we just do this, and this will be first. That makes sense? So the first one is 4, A is first, and then we start going. Okay, that should fix that. And so if we just look back at engine.cpp for a sec, xnorm will still work off of the mouse, but as soon as I press R, for one frame it should change color. So let's do that now. I'll put it down here. You can see, I don't know if you saw that, it did flash. I'll just spam it a little bit. Hopefully you picked up one of those. But the key there is that I'm pushing down, and it's only turning on for one frame, right? I can do the same on up. So key up. This is showing you that. So in this case, as soon as I release it for a single frame, I know that the key has just been released. So I just pressed it, and now I'll release, release, release. Do it fast. Hopefully you'll see a couple of them. Okay. So now the obvious key, you should just apply that as long as I hold it down. And you can see it does. So that's working pretty well. So maybe what I'll do now is maybe we'll just have an offset. So let's just get rid of this. Maybe we'll just have an offset here. So float x key offset equals 0.f. Y key offset equals 0.f, and then maybe we'll just sort of accumulate offsets based on the key. So if I press hippo input key left, we'll say x key offset minus equals, I don't know, let's have a float key speed. That's probably good. We don't have to define it here every time. Just keep it once up here. And this is just, it has to be like this because my update loop's going to run really quickly, so I want to slow it down. When we have something like a fixed update loop, we can fix that again once we get to sort of client app stuff. But here, I'll just say, we'll just minus equals key speed. There we go. And we'll just do that for left, right, up, down. So right we add, and then up we remove, and down we add. Wait, is that right? No, it's backwards. Up we add, and down we remove, because OpenGL's coordinate goes positive is up. Okay, so now I can define the sort of offset that starts at 0, 0, and I'll just say x norm plus x offset, x key offset, y norm plus y key offset. So a little combination here of both, where I should be able to at least see that they're both working as expected. So I'm moving my mouse, and now we'll use the arrow keys, and I'll hold right. And it's not working. That might be too slow. Let's just remove a 0 here. So now I'll hold right, and yeah, you can see it moving there. So holding right, holding left, holding up, holding down. And so you can see as we do that, that happens, and then our mouse offset still works as expected. So I can make my mouse being at the bottom left be fully black by moving it to the left and right, and then my mouse coming up will be fully yellow. Or here's where you're at the 0.00 bottom left sort of thing. And I can keep changing that offset with my keyboard. So coming back to the mouse real quick, I noticed we set up X last and Y last, we never used them, so let's do that now. We just have X last equals X here, Y last equals Y, and then to use them, we could expose like a delta X and a delta Y. So if I say dx, dy, I would want X minus X last and Y minus Y last, right? And so if we just try that real quick, in Engine, we currently use the normalized X and Y positions, but maybe instead of that, we'll just say X norm and Y norm could be delta X and delta Y just on its own. Let's just try this for a second. Delta X, actually we can, that's fine. Delta Y, And what I expect to see is we can sort of, if we move the mouse fast enough, we'll see the color change, but then if we stop moving, it'll go back to center. Or to 0, 0, so yeah, there, that's working. And so obviously the delta is really strong, so we can just divide this by something. Let's say divided by 100, point f. That way a 3 pixel delta will be a 0.03 change in the color. So there, you can see that it's the delta sort of working as expected, right? And if we move it like a lot in one frame, you can see we see a lot more red there, but it eventually sort of settles back into the middle because the delta becomes 0. So that's one thing that I wanted to fix. Another is that I'm only just realizing that we have it, like, we don't need a down and an up, we just need a last. So by having last, we save ourselves the extra array, and we just copy everything over, and then sort of do this for the current one, and then in here we'll just check against both. And let's just go ahead and do that, because we'll save an extra array. Buttons and buttons last, yep. So we don't need this, we want buttons last to be cleared. We don't actually want to do any of that. With std arrays, we can say buttons last equals buttons. And I don't know if this internally just does a mem copy, because it should be contiguous, but let me just add an optimization to do. Is mem copy faster? I'm not sure. I'll just keep it here, and then yeah, we'll get the state, we have the X and Y position, and then for every button we'll just get the button. Right? And so these, so if it was down and it's no longer down, that means it's been up. So this check just becomes button is fine, button down is if buttons and not buttons last, button -1. Right, so if it's down now and wasn't down before, and then for buttons up, it's if it's not down now and it was down before. Right, so if it was down before and it's not down anymore, then button up is true. Okay, let's give that a quick shot just to make sure we didn't break things. In engine.cpp, good, we've dealt with delta. Let's go back to this and we'll just say maybe if this I'll just say if mouse button down, and I'll say hippo input mouse left, hippo input mouse right. So if I just pressed the left click only for the first frame, I'm gonna say minus equals x key speed times let's say times 10. That'll be a big change. Otherwise, this times 10. Okay, so we're doing this really just to make sure that we didn't break anything with the way it was just working. So here I am, and then if I click, so there's that sort of slightly big change. It only happens on the first click. Same with the right click, it takes me in the opposite direction. Can make this a little more easy to see. We'll make it times 100. Which would give me 0.1, so it'll be 10% of the full color. And so there, if I'm clicking, you can see it's moving correctly. So that's perfect. I want to do the same thing for the keyboard, because the keyboard is really where we're going to see the gains. So we'll say keys and keys last. So same thing here. Keys and keys last. When we initialize, we set keys and keys last to false. Don't need these fills, we'll just say keys last equals keys. Okay. Oops, did I get rid of that mouse? I did, yeah. So keys at I equals state at I, perfect. And so in here, key, return keys at I, keys down, return keys at I, and not keys last at key. Oops. And for keys up, we'll say keys, not keys, and keys last at key. So in engine.cpp, we'll do this, and maybe I'll just come back to this, but in this case, we'll just go back to key down. And this is keyboard. And so if we just go here, I should see a big jump and then a slow gradual change. And that's exactly what I see. Okay, perfect. I think that is better just because we save on that extra array. So there we go. We have the ability to detect and react to mouse and keyboard input. The joystick one is going to be a little more intricate, like actually a lot more intricate, just because of the way that game controllers work on SDL. So we'll leave that one for a next video. But until then, I hope this was useful, and I'll see you next time. Thanks for watching.